This looks like an ordinary bowl of instant noodles, but the unusual ingredient behind it starts in a completely different form. The starting ingredient is yellow mealworm, the larval form of Tenebrio molitor, handled here as a controlled food production material.
The real mystery is the middle. How does a visible insect ingredient become a fine powder, then disappear into familiar noodle dough? The transformation begins with scale. Hundreds of shallow trays create a controlled indoor farming system before any food processing even starts.
This stage, the most important visual is not machinery, but consistency. Healthy-looking trays, even substrate, and careful handling across the room.
Every transfer is kept shallow and supported, so the ingredient never becomes a chaotic pile, and the factory still reads as food production.
The first impossible step is already visible, but only for a moment. Once dried, the recognizable shape is about to vanish. Far downstream, the ingredient has become something completely ordinary, a continuous sheet that can be cut into thousands of noodle strands.
To understand that contrast, the process has to restart at the handoff point, where farming ends and controlled food processing begins. Breeding is organized vertically, letting workers inspect many shallow trays without mixing different growth stages or disturbing neighboring racks. The feed layer stays shallow enough for workers to see movement and condition at the surface, instead of burying the insects in deep material. Moisture is managed inside each tray as a separate input, helping the crew keep the growing environment predictable from rack to rack. The breeding hall is really an airflow system with insects inside it, because heat and humidity can change quickly across dense rack rows. Rotating selected trays makes inspection easier and prevents the same rack position from becoming the only condition a batch experiences. Keeping growth stages separate creates the first real sorting decision long before the ingredient reaches any stainless processing machine. The harvest decision is based on batch condition and size, so the next room receives a more uniform raw ingredient instead of mixed stages. This is the last point where the ingredient still looks exactly like the title promises. From here, each room removes another familiar feature. A one-way tray route prevents finished handling from colliding with returning equipment and makes the process easier to follow visually. Before processing can continue, loose feed and fine substrate have to be separated from the insects without turning the room into a dusty mess. The first mechanical transformation is simple separation. Smaller particles drop away while the larger mealworms continue across the upper surface. Moving the loose substrate also changes the image immediately. The ingredient is now easier to inspect because the background clutter has disappeared. Machines create consistency, but people still catch irregular pieces at the belt, where color, shape, and movement are easiest to compare. By the end of harvesting, the factory has not changed the ingredient chemically. It has only made the incoming material more uniform and traceable. A short controlled holding stage creates a clean break between farming and processing, with each batch kept separate before the food safety transition.
Under bright light, irregular debris becomes obvious, so this inspection works best before moisture or heat changes the surface appearance.
The perforated basket becomes the support surface for the next steps, keeping the ingredient contained while allowing water to drain quickly. A brief rinse removes remaining loose particles, but the visual goal is controlled cleaning, not dramatic agitation or messy splashing. Draining matters because every extra surface drop becomes moisture the drying system would otherwise have to remove later. Cleaning makes color and condition easier to compare, giving the crew one more chance to remove anything that does not belong. Now comes the point the camera deliberately handles differently. The raw insect form is about to become a stabilized food ingredient. Heat treatment is shown as guarded food technology, with the material enclosed and the operator separated from steam, hot surfaces, and moving parts. The machinery changes the scene before the material reappears. Steam, condensate, and controlled. When the camera returns, the ingredient is no longer presented as a live handling scene. It is now a stabilized material ready for drying. Removing surface moisture here protects the next stage from wasting energy on water that can be drained before drying begins. A thin, even layer gives the dryer a more consistent target, because thick piles would trap moisture and slow the center of the batch. This handoff is visually important. Recognizable shapes are still present, but the next room is designed to make them dry, brittle, and millable. Drying does more than remove water. It creates the brittle texture needed for the ingredient to break cleanly during milling.
At the tunnel exit, the ingredient still has a recognizable shape, but its texture has changed from flexible to dry and brittle.
Cooling stabilizes the dried material before grinding, preventing trapped heat from carrying into the sealed powder handling equipment. The simplest visual clue is the break. Material that fractures cleanly is far closer to powder than anything seen in the breeding hall. The grinder never receives a live ingredient in this depiction. It receives only dried, stabilized material from the previous controlled steps. Inside the mill, repeated impact and shear destroy the remaining visible structure until the output behaves like an ordinary dry ingredient. This is the first major payoff. Once the dried material becomes powder, the original insect shape is no longer visible at all.
Sifting creates a more uniform particle size, which matters because uneven powder can hydrate differently when it reaches the dough mixer.
At this scale, the ingredient looks less like an insect product and more like any other finely milled dry food component. Smooth flow is the visual sign the drying and milling stages work together. Damp clumps would behave very differently in the next room.
The ingredient has crossed the biggest visual gap, but one question remains. Can this powder behave inside dough without taking over the texture?
Quality control begins before mixing, because the next stage depends on a dry ingredient that can be dosed consistently from batch to batch. Separating clean powder transport from returning equipment keeps the transformation visually one way and prevents the factory from feeling like a random loop. Here the role becomes clear. Mealworm powder is an added ingredient, while wheat flour still provides the main structure for noodle dough. The color contrast makes the formulation easy to read. Two dry streams remain separate until the dosing system brings them together.
This is the impossible step in its clearest form. A recognizable insect ingredient has become powder, and now even that identity begins disappearing.
Once dispersed through flour, the ingredient is no longer a separate visual object. It becomes part of a single dry formulation. The powder stage ends here, replaced by a blended flour base that can finally enter the familiar mechanics of noodle production. The strangest part is over. What began as a visible tray-grown insect now moves through the factory as an ordinary-looking dry ingredient. Water starts the second transformation, activating the wheat proteins and turning loose powder into a material that can survive rollers and cutters. Noodle dough depends on controlled hydration, so the liquid enters gradually instead of flooding the dry blend all at once. At first, the mixture looks wrong for noodles, more like damp crumbs, but this texture is exactly what the rollers can consolidate next. The mixer does not need to make a finished sheet. It only needs to distribute water evenly enough for resting and compression to finish the job. A short rest allows moisture to spread through the particles, making the next compression stage more predictable and reducing dry pockets. The rollers perform the visible magic. Disconnected crumbs become one continuous sheet without needing the dough to look smooth beforehand. Folding and compression build a more even structure, turning a rough slab into something strong enough to survive repeated reduction. Each roller pair makes the sheet thinner while keeping it continuous, so the material changes geometry without changing direction.
Edge trimming removes weak, irregular borders, leaving a clean, continuous ribbon that can be measured and reduced more precisely. A tiny thickness difference becomes obvious later when strands cook unevenly, so measurement happens before the sheet reaches the slitter.
By now, no visible clue points back to the original ingredient. The material looks like ordinary noodle dough under bright factory light. The line now works continuously, with each stand handing the same supported sheet forward, instead of creating separate batches.
Synchronized rollers prevent sudden stretching, because every downstream section has to accept the sheet at nearly the same pace it receives it.
This final reduction creates the thickness needed for strands, completing the dough building phase before any cutting begins. The next machine will finally make the product recognizable, because one flat ribbon is about to become hundreds of parallel strands. One last second, the material is still a sheet. After this guarded blade set, the finished product begins to announce itself visually. The first noodle strands appear instantly, turning the abstract flour blend into a product shape every viewer recognizes. Clean separation matters because strands that merge here would create thick spots that steam and dry at a different rate.
Failure wave is formed mechanically before drying, using controlled belt speed and guidance rather than shaping each strand by hand.
The line now reveals both ends at once. Pale, soft strands enter the hot section, while firm noodle cakes emerge far downstream.
Steaming sets the noodle structure before drying, giving the strands enough cohesion to keep their shape through the final moisture removal stage.
The steam remains inside the cabinet, while the conveyor keeps the product moving at a constant depth and direction.
After steaming, the strands look more cohesive and glossy, but they still contain too much moisture to behave like instant noodle cakes.
Portioning changes one endless ribbon of strands into repeatable serving units before the pieces are shaped into compact cakes. The forming pockets create the geometry consumers recognize, while the noodles are still soft enough to settle without breaking. Drying now becomes the final major transformation, removing enough moisture for the cakes to become light, firm, and shelf-stable in this depiction. Even spacing lets hot air reach each cake from similar directions, reducing the chance that the center stays softer than the edges. The product now looks almost finished, golden, rigid, and light enough to travel through packaging without collapsing under its own weight. Cooling matters before wrapping, because trapped heat can create condensation inside a sealed package and undo the work of the dryer. A good cake has to survive handling without crumbling excessively, so workers inspect structure before the product reaches wrapping equipment.
This is the visual payoff promised at the start. The strange raw ingredient has disappeared into a completely familiar noodle cake.
From this point onward, the transformation is complete. The remaining work is inspection, portion control, sealing, and logistics.
The checkweigher catches unusual portions without slowing the entire line, separating process control from the visual inspection done by workers.
Humans look for obvious structural defects that sensors cannot summarize as simply as a quick glance at shape and surface.
The seasoning remains separate from the noodles until packaging, letting one upstream noodle line support different final flavor formats. The wrapper creates a protective barrier around the dry cake, but the packaging stays visually plain, so the process remains brand neutral. A clean seal turns the open film tube into an individual pack, isolating the dry product from the humid factory air. The seal is checked before cartoning, because a weak seam can compromise the product, even when the noodle cake itself is perfect. Final inspection systems sit after sealing, so each complete pack is checked in the same form that will leave the factory. A short accumulation section absorbs small speed differences between wrapping and cartoning without forcing workers to handle loose products by hand. Cartoning changes the scale again. Individual servings become shipping units that are easier to stack, count, and move through a warehouse.
Once sealed, the product no longer needs delicate handling. The factory can move it with ordinary pallet and warehouse equipment.
Pallet stacking converts dozens of small packages into one stable logistics unit, completing the factory side of the journey.
The manufacturing process ends here, with the strange starting material now hidden inside a familiar product ready for ordinary distribution. Seen at warehouse scale, nothing about the final product reveals the unusual ingredient story that began back in the breeding racks. Process has come full circle to the object shown in the opening shot. A compact, familiar instant noodle cake.
Add hot water, and the rigid cake begins relaxing into soft strands, revealing the final texture the entire factory was built to create. The finished bowl looks ordinary, which is exactly why the transformation is so surprising. Almost every visible clue from the beginning is gone. From tray-grown mealworms to dried powder, dough, strands, and a finished bowl, every stage removes another piece of the original appearance.
And that brings the journey back to where it started. An ordinary noodle cake carrying a manufacturing story most people would never guess by sight.